This question is a continuation of question 2. So if you have not done question 2, I encourage you to go back and look at that first. And then this question says, okay, now come up with a 90% confidence interval for the difference in proportion of malaria infections among the two groups. In other words, in the previous problem, we found that we do think that there's a difference in the infection rates. What is that difference? I'm not positive, but I can come up with a 90% confidence interval. So first of all, I need to use the same conditions that I did in the previous problem. Now, when we go through something like this, the people grading it aren't fools, but they do want to see that you've got an understanding of what's going on. So I will use the same conditions as the previous problem. I don't need to rewrite all these, but this does make the connection for somebody grading your work, that they understand that you understand conditions are important and the conditions are exactly the ones you used in the previous problem, and I don't need to check them differently because it's the same problem. It's just another part to that. Now, to find a confidence interval, again, it's that typical formula, the estimate plus or minus a critical value times the standard deviation of the estimate. And so now my estimate is p hat 1 minus p hat 2 plus or minus a critical value. Now I've got a 90% interval, and on my 90% interval, that's going to be a critical value of 1 point, oh, sorry, I should do it in symbols first. Z star, it's going to be 1.645. And then the standard deviation is the square root of p hat 1, 1 minus p hat 1 over n1 plus p hat 2, 1 minus p hat 2 over n2. Now I don't have to fool here because I haven't done a hypothesis test for this kind of problem, so I'm not considering P1 and P2 to be equal to each other. So when I plug the numbers in here, this is going to be 36 over 136 minus 152 over 407 plus or minus, there's my z star, times the big square root of 36 over 136 times 1 minus 36 over 136 all over 136 plus 152 over 407, 1 minus 152 over, 152 over 407 all over 407. And as before, I won't do this formula the long way. I'll grab my calculator and I press stat test, and this is a 2-prop z int. If you've done the problem before, the numbers are still there. It's a 90% interval. And so I calculate it to get this interval. Now, since both of these numbers are negative, that means that I'm pretty sure that this number is actually smaller, which is congruous with what we did in the previous problem, that the proportion of kids with sickle cell who get malaria is actually less. And so I write down my interval, negative 0.1824 to 0.0351. And generically, my conclusion will look something like this. I am 90% confident the true difference in malarial infections with children who have sickle cell and those who don't is somewhere between negative 0.18 and negative 0.035. And again, since both those numbers are negative, that is, since these numbers are both negative, I think children with sickle cell get malaria at a rate, that's two words, a rate somewhere between BTWEEN between 3.5% and 18% lower than non sickle cell children. And that's how you would do a two proportion confidence interval.